Yodel, let's do some proofs. Okay.
Should that be your opening?
Yeah, let's see. Yeah. I should be the yodeling mathematician. Okay. We're going to hunt down some proofs today, Switzerland style, right up in the Alps. Let's do this. I got 3 examples here I want to cover today. The first one is a little bit longer proof, 5-step proof. Yesterday we did a bunch of 3 and 4-step proofs. Can you hear me on this thing? Is this working? Hello? Hello? Yeah? Okay. So I want to maybe let's walk through the first one together, and then the second one we'll give you a try at with a partner, and then we'll go from there. So PRLG is a parallelogram. What do you suppose should be the justification for that? Given, right? It's written right here, given. Okay. Given. All right. PR is parallel to GL. PR is parallel to GL. How do we know that? Because it's parallelogram. So I'd say right here, definition of, I'm not going to spell the whole thing out, parallelogram. It's kind of like Heart Week all over again. Heartogram. Please write it all the way out on the test. I don't want to come up with like different ways to say parallelogram. So write it all the way out. I just don't have enough space. Okay, we also know that PG is parallel to RL. So that's going to give us some information. What does it give us about alternate interior angles? They're congruent, right? So that leads me to this. RPL, this angle right here, is congruent to GLP, that angle right there. Same thing with GPL and RLP. What would be a good justification there for that one? Okay. So I would be just fine with you writing alternate interior angles lasagna. All right, congruent. That would be a good justification there. How do I know that something is congruent to itself? By what property? Reflexive property. And take about 30 seconds right now and talk to a neighbor about what you think the congruence conjecture would be for this proof. Spencer, what'd you pick? Angle, side, angle. I like it. Right, if you pick side, side, side here, you're just a fool because we don't have more than one pair of sides. So don't be that child. We only have one pair of sides, so that would eliminate side, angle, side as well. So I could see maybe screwing it up and going angle, angle, side, but it still wouldn't be right, so that's out. So we would know angle, side, angle. Of course, if you ever put one of these in a proof, that would be sad because those are not congruence conjectures. Great. Little do. Example 2. All right, start number 2 of the neighbor. We'll give you 2 or 3 minutes to get a good start, and then we'll check it out. Okay. Let's give this a try. What do we know? First thing I want to do is I want to know what triangles I'm trying to prove congruent. So I would do a little highlighting if I were you. And I would highlight the 2 triangles. Here's ITA. And let's find our other color up here. We'll go good old Packer lifestyle here. Okay, I'm trying to prove those triangles congruent. All right, because of all this overlapping stuff going on here, I want to do that just so that it can clear things up for me. Okay, so now let's do some marking. Angle S and angle I are congruent. S and I. Angle G and angle A are congruent. Okay, I got 2 angles in both of those. I just need a side, right? And that side needs to be placed appropriately. Let's see what we got. And T is the midpoint. T is the midpoint of SI. So that means this. Are we okay with that? If T is the midpoint of SI. All right, so what I would do is I would first start laying out my proof a little bit, and then I'll go back and look at the triangles to figure out which of my four conjectures that will apply to. So what is given? Well, what's given is angle S is congruent to angle I. What else is given? Angle G is congruent to angle A. Now, I could put both of those in the first line and just use a three-step proof instead of four, but I'm going to do this. This is totally okay. It just requires a little bit more writing. So do I have two angles? Yes, I'm good so far. Definition of midpoint. How would I use the definition of the midpoint to help me here? Not RT. P is the midpoint of SI. So what two segments are now congruent, Nick? IT is congruent to what? ST. Good. You agree? Based on that logic, I can say that triangle ITA is lasagna with triangle STG by what? Well, let's see. Let me see if I can drag this yellow one out of here for a moment, just so I can see it. If I recall correctly, I have angle here, I have angle here, I have side there. That looks to me like angle, angle, side. If you wrote that as side, angle, angle, that would also be acceptable and correct. Okay, proof complete. Did I do the signature yesterday? Yes. Do your signature, right? A little completion of that proof, and you move on. Okay, let's do one more. I don't think we give you anything on this one. This is great. This is a standard two-column proof where you get nothing. There's no template. I mean, you have this nice layout, but you don't have much other than what's given and what you're trying to prove. Okay, so the first thing I'll always do is I'll highlight the triangles that I'm trying to prove congruent. In this case, it's fairly easy to see them because there's nothing overlapping, but I'll do it anyways. So I'm trying to prove ACB congruent to, we'll go for you Vikings fans, since you're, 84 million in the hole now, to that triangle. Let's prove them congruent. So if C is the midpoint of AE and BD, if C is the midpoint right here, that tells me what about AC? What's it congruent to? CE. What is BC congruent to? Has to be congruent to CD. How do I even know that? Well, because that's the definition of midpoint. It cuts it in half. Okay, so what I would probably do is, I would probably just replace this. C is midpoint of AE and, oh, that's an 8. Wow, that was a great attempt. And BD. What would be the justification? Given. I show you the stinking yodeler, and now you're all quiet. I thought that would maybe rev you up a little bit, but okay. Now we've determined that AC is congruent to EC. I'm going to do on this slide what I told you I was skipping on the last one, but I'm going to put two statements here. BC is congruent to what? DC. Very good. Okay. Now, both of those are true based on the definition of what? Definition of midpoint. Definition of midpoint. We need one more thing. We got two sides. Can we say that AB is congruent to DE? No, we can't. We don't have enough information for that, but we do know this. What kind of angles are those? Yeah, they're vertical angles. So angle ACB is congruent to angle ECD. Vertical angles are congruent. Therefore, we're almost done. ACB is congruent to triangle ECD. by what? Side, angle, side. Done. Yodel little. Subscribe to my channel. Yeah.